Picking up from where we left off, comparing film negs to camera sensor pixels, let's now go over to pixels to droplets in detail. We take a picture with a full frame 36 megapixel digital camera. So we've got a beautiful Nikon D800 over here. We've captured, let's say, 7,360 pixels by 4912 from the CMOS sensor measuring 36mm by 24mm. Now that's 1¼ inches in that direction by 0.9 of an inch in that direction. So approximately an inch by 1.5 inches. This sensor captures a total of 36,152,320 pixels in total. So this is effectively our digital neg. That's the modern equivalent of the neg that we used to use in the darkroom. Now our camera resizes these pixels internally to 72 pixels per inch at an image size of 102 inches by 68. So you've got all of this information coming into this case, into Photoshop, and we're actually seeing that the pixel dimension is 4912 pixels by 7360, which exactly corresponds to our data. So this is the pixels coming in to our image editing software, and the camera has decided to size it all up at 72 pixels per inch, and because it's 72 pixels per inch, it calculates up to 68 inches by 102. Now we still have the same number of pixels, see this here, same pixels here as actually inside, in this case Photoshop, it could be Lightroom, just the same. We have the same number of pixels, but it's at a different scale. Now it's a bit like starting out with pixels the size of postage stamps and then ending up with the same number of carpet tiles. Physically much bigger, but containing exactly the same amount of information. Notice on this screen grab that we have just over 103 megabytes of file size from what we understand as 36 million pixels. As this is an 8-bit file with 3 color channels, that's red, green and blue, we multiply our megapixel count by just under 3. If it was a 16-bit file in RGB, we would multiply by just under 6. Conversion from megapixels to megabytes is a complicated subject, so let's keep things simple and just talk about millions of pixels. So we've got 36 million pixels there, and it's gone into, in this case, Photoshop, and we still have 36 million pixels if we multiply that figure by that figure. Now, the image file is transferred to our computer software, say Photoshop, Elements, Lightroom, whatever, and we prepare our image in this software to a manageable image size that our inkjet printer can handle, usually by image resize or the image crop tool. Now in this case, to A4, so we've got 21 centimeters by 29.7, or for our US friends, imagine that this dimension is 8.5 inches and that dimension is 11 inches. There's very little difference. As a resolution that for nearly 20 years we've all been advised to set at around 300 pixels per inch. This gives us an image file of around 3508 pixels by 2480 pixels, just over 8.5 million pixels. Or in this case, look at this, it's just under 25 megabytes. So what we've just done is we've resized from our original pixel count of 36 million pixels, and we've resized it in the conventional manner so that we're resizing to 300 pixels per inch, and we've come from 36 million pixels, and it's gone all the way down to 8.5 million pixels, or if we're talking about megabytes, it's come from 103 megabytes, genuine file size here, all the way down to just under 25 megabytes, because we're preparing this in the conventional way for print. Now let's break here and we'll continue in the next movie.